If it's been a while since you graphed something in point-slope form, give this one a try. Pause the video now. Here we're flipping things around a little bit, and we're asking you, given a point and a slope, to write the equation in point-slope form. This could be review, but do it with a partner and make sure you're understanding what's happening to your signs on that coordinate pair. Pause the video and finish this slide. Here's what those equations look like. Believe it or not, you just wrote equations for a line. You were given information, the point and the slope, and you, hopefully, could put these right into the point-slope equation and come up with these outcomes. So in a sense, you've already reached your learning target because you've done this before. You've also done it with slope-intercept form. So this lesson will be pretty much a review of how to write equations either in slope-intercept form or point-slope form. Here's a twist. Here you're given the graph. And normally you'd be asked to write the equation of this line in any form. But I'm going to specifically ask us to write it in point-slope form. So if you're looking for point-slope form, the first thing you would do is look for an easy coordinate pair. And I actually have two here that have little tiny black dots. So you only need to pick one of them. And pick the coordinate pair. So we'll take this one here. This coordinate pair is 1 for the x-axis, and then we went up 1, 2, 3, 4 to get to it. So that point is 1, 4. Then we want to look at the slope between the 2 points. So I'm going to rise and run from this point to the second one. 1, 2 up, and 1, 2, 3 over. So that makes our slope a positive 2/3. And now it's just like the problem on the previous slide, and we can write it in point-slope form. We also could have used slope-intercept form. The slope is the same for both situations. It's 2/3. The problem with using slope-intercept form for this graph is you would have to estimate what that y-intercept is because it's not crossing the grid right at an intersection of the square. So in this case, it's better to use point-slope form. And you know from a previous lesson that you can turn this point-slope form right into slope-intercept if you wanted to. Let's try another one. And we're going to use point-slope form again because this is really not a convenient point for y-intercept if we used slope-intercept form. So begin by finding the 2 points that I highlighted, and they're here and here. I know they're super tiny. Pick one of them, it doesn't matter what. In fact, you could pick a different one than me. I'm going to pick this one over here, which is at negative 1, 2, 3, 4, and it's up 1, 2, 3, 4. So my coordinate pair there is negative 4 and positive 4. My slope is the rise and run from one point to the next. So down 1, 1, 2, 3, I think that's it. Let me try it again. Down 1, 1, 2, 3. Okay, so my slope there is negative 1 because I went down, and 3 to the right. So in my equation for my point, I would have y minus 4 equals negative 1/3 x plus 4 because of my negative 4 in the coordinate pair. And you're done. Let's say you pick this one here. And your coordinate pair was negative 1 and 3. I'll do it in a different color. You do not have to do this both ways. I'm just showing you that you're going to get the same answer eventually. So let me write this one down here in point-slope form. Y minus 3 equals negative 1/3 x plus 1. Now if you did it with the negative 1 and 3, or the red coordinate pair, negative 4 and 4, these look like they're totally different answers. But they truly are not. They are the same equation for the same line. And we can prove it by putting them into slope-intercept form. To do that, you would first multiply through, for both of them, the slope of a negative 1/3. Down here, I would get y minus 3 equals negative 1/3 x minus 1/3. Your next step in the red equation would be to add 4 to both sides. So my final answer, and you have to do some fraction work, is 4 minus 1 1/3. That's what this combination is here. 4 minus 1 1/3 is 2 2/3. If you turn that into a decimal, it would be 2.3 repeating. Oh wait, I said 2/3. That would be 0.6 repeating. Okay, so there's the equation for my red one converted into slope-intercept form. I'm going to do the same for my blue one, finish it up by adding 3 to both sides. These cancel and you get y equals negative 1/3 x, and then I have a positive 3 minus 1/3. And that's 2 2/3 again, which converted into a decimal form is this. So look, they truly are the same equation. They just don't look that way in point-slope form. But they have to be. It's logical because both those points came from the same line. Let's try this one. Again, we'll do it in point-slope form, and then we'll prove it's the same equation by doing it in slope-intercept because this one is crossing the y-intercept really nicely. So let's start with point-slope and finding those little black dots that are so tiny. I see one right here and I see one right there. So let's use 1, 2, 3 to the left. So that would be a negative 3 and down 1. Then my slope is going down 1, 2, 3, 4. I passed it. 1, 2, 3. Down 3 and over 1. So your slope is a negative 3. Let's put it in point-slope form. That's what that would look like, and these will become positive. So that's what the equation looks like in point-slope form. We can do it in slope-intercept form too. You normally will never have to do it in both forms. I just want to show you that it's possible. Notice which form I'm not using, and that's the standard form. We rarely write equations in standard form. So if I was using slope-intercept form, my slope is going to be the same. In this case, my y-intercept looks like negative 10. And it is. So writing it as y equals mx plus b. Well, are these the same line or not? You can always test it out by solving this one up here. You have to distribute first. And making sure that they end up being the same equation. So you're going to subtract 1 now from both sides, and there you'll see it, that your final result will be, let me write it down here, y equals negative 3x minus 10. So again, I was showing you a lot more work than you're probably ever going to have to do. I just wanted to prove to you that it doesn't matter which form you pick, as long as you can pick out the data you need, whether it be the point and the slope, or if it's the slope and the y-intercept. Well, let's take it up one more difficulty level because that was pretty simple. Here you'll be given only 2 points. That's all you're given. And from these 2 points, you can still write an equation of a line. And point slope will be the easiest line to write an equation for. If you're given the points 5 and 2 and negative 2 and 3, your first job is to find the slope. Slope, if you recall, is y2 minus y1 over x2 minus x1. Use that equation on these coordinate pairs. Your y-coordinate of your second point we'll say is 3 minus the y-coordinate of your first point, so that's these two right here. Keeping the order the same, I'm going to take the x-coordinate of the second point minus the x-coordinate of the first point and simplify. You get 1 over negative 7, or the fact that the slope is a negative 1/7. Well, that was all the information you really needed, because to write in point-slope form, all you need is one point and the slope. Well, which point do you pick? This one or that one? The beauty is it doesn't matter. As you saw on the previous slide, you can pick either this point or that point, and it will still be the same equation for the same line. They'll just look different from each other until you get them in slope-intercept form. So I'm going to use my point. Let's see, I'll just pick the first one. 5 would go here because it's my x-coordinate, and 2 would go there because it's my y-coordinate. And my slope, I know now, I would replace my m with negative 1/7. And you're done. There's no need to rearrange that into slope-intercept form unless you're specifically asked to. This is its very own legitimate equation for a line. So let's give it all the credit it's due and leave it in point-slope form. We can never get enough practice with this, so I would like you to do these 3 problems as your guided practice. And we're going to write them in point-slope form. If you wanted to take it a step further and switch it to slope-intercept to compare your answers, go ahead. But for now, pause the video and get started working.